You are welcome to my grade advances, and I have this lesson on algebra. And talking about algebra, we'll be learning about how to expand and factorize algebraic expressions. And the basic objectives of this lesson is for you to be able to expand brackets, and also for you to be able to factorize algebraic expressions. Now, hang on a minute. If you have been struggling with algebra, I guarantee this lesson is for you, right? If you follow all the simple things we'll be talking about in these lessons, you would be glad and you'll become more confident handling algebraic expressions. Now, did you know that this is going to be the first thing I'm going to say to you, that the algebraic functions have the same rules that you used for numbers. I'll say that again. Algebraic functions or algebraic expressions, or whatever you have been calling them, but I'm saying algebraic functions follow the same rules you use for numbers. In other words, if you know how to add 2 to 3, you know that 2 plus 3 is equals to 5, then for you to do the same thing with x plus y is easy. The only difference between 2 plus 3 is you know what 2 is and you know what 3 is. You know, 2 is 2, 2 is a constant, 3 is 3, 3 is a constant. So you had 2 things to 3 things and you got 5. Now, on the other side, in algebra, we are not so certain. We're not so sure. So we have these numbers like x plus y. So if you see something like x plus y, since you don't know what x is, and you also don't know what y is, it becomes impossible for you to add them. Now, let's take a look at algebra. Let's start to follow the objective of this lesson, to first learn how to expand brackets. And then afterwards, we'll come back to see how you can factorize algebraic expressions. Good. Now, let's start to build the fluency of algebra. Now, think about this particular question that we have here. And in this question, we have the task to simplify the following. So we want to simplify y times y. And we're going to simplify 4x times x. And we're also going to simplify 3x times y. And finally, we're going to simplify s times r. Now, you can hang on for a moment and you feel, well, no, this is not my struggle with algebra. But I can tell you, this is where it all started from. The simple mistakes you made when solving problems in algebra, I believe they started from here. They started from you not being able to simplify some simple tasks or making some silly mistakes that can cost you marks. All right. Now, I started saying earlier that if you can do 2 times 3, you know what 2 times 3 is? That 2 times 3 is 6. Then I can tell you, you can do y times y. Now, in this case, you know, y is y and y. They are both the same. It's the same thing. I'm doing this because I have said the same rules that apply to numbers also applies to algebra, also applies to algebraic functions. So if I say 2 times 2, of course, we go directly to say 4. However, I can write 2 times 2 as 2 raised to the power of 2. But we don't write it this way because 2 is a constant number. We know what the value of 2 is. We know 2 is 2, so 2 times 2 should just be 4. However, on a daily basis, you could find 3 to the power of 2. And 3 to the power of 2 is the same thing as 3 times 3. The number is multiplying itself twice. So 3 to the power of 2 is 3 times 3, and that will be 9. Now, we could get 9 because we know that these numbers are constant. Now, when you have y times y, what does that give you? Y times y is y squared. Okay? The same thing that happens to 2 times 2, or 2 raised to the power of 2, that is the same thing as 2 times 2, 3 raised to the power of 2, that is the same thing as 3 times 3. When you have an unknown number, which is an algebra or a variable, you have them like this, and you have multiplication, you want to multiply them. What you get is a power of that algebra. So y times y is y squared. Now, I see you started to get that. Okay, look at the second question. If we do 4x multiplied by x, what do you observe? We have a constant, which is 4. 4x multiplying x. Now, again, you notice that when a number and an algebra, when they are written together, you must know that what the kind of operation between them is multiplication. So this is the same thing as 4 times x. 4 times x will always be 4x. So for you to see what I'm saying, I can write this as 4 times x times x. And that will give 4 times x is 4x. But I opened this up because I wanted you to see what we just did in the first question, so that you can see x times x will, of course, be x squared. So I'll be left with 4 times x squared. Now, a constant multiplying a variable will always be written together, so we can write it as 4x squared. Do you see? It's getting more interesting. Now, look at the third question. X times y. X times y. Now, in this case, we don't know what x is. We don't know what y is. They are not the same. So we just write it simply as xy. Now, I see you want to answer question 4 because you can do that. So when you do s times r, what is that? Excellent, excellent. That's x, SR, XR. So that's how to get started. And we are still coming back to look at how to expand the bracket. But this is first the foundation to be laid before we can proceed. Now, let me give you something for you to try your hands on. So what do you think the result of this, what do you think it will be if I ask you to do 2p multiplied by p? 2p multiplied by p. What will your result be? Okay, excellent. If you have done that, it's just similar to the question we had. This was the second question, very similar to this. So you do, that should just give you 2p squared. And how did we do that? It's going to be p times p, that's p squared, and p squared times 2 will be 2p squared. So follow me again as we continue to look at how to expand brackets. Now, let's proceed with other questions. Now, at this time, we want to see examples on how to expand. How do you expand, or how will you expand the following? Now, it's very simple for some people. This is not what you really need, but I know for a number of people, this is just what you need to get you started. How do you expand the following? To expand a bracket, okay, listen to that. To expand a bracket, you have to multiply each term or each number inside the bracket by the term or number outside the bracket. Okay, in algebra we have some words like terms. Because this letter X is not a number, it's a letter, but we have employed it in mathematics. We call them variable. Then when it is written as X plus 2, that's a term because we don't know what that is. All right. Now we're saying if you want to expand these brackets, you want to expand any bracket like this. If you want to expand this bracket, what you have to do is you are going to multiply each of this term. That is, you will multiply X and you will multiply 2 by the term outside the brackets, which is this 4. Now, how do you do that? Let's look at that together. So for the first one, we have 4 into the bracket X plus 2. Now, this is a very simple one. So I will start with multiplying 4 with X. So like we did in this example, 4 times X will give you 4X. Good. And then plus. Why did I write plus? Because when you look at this number 4, it's positive. Any number that is positive, we don't write the positive sign if it's alone. So 4 is positive and this is also positive, then I can write the positive sign. Now it says the next thing is to use the same 4 to multiply the second term, right? So it will be 4 times 2, and that will be 8. You're doing well. Okay, so let's do the rest together. Now, the B part, we have 3 into the bracket of Q minus 5. Q minus 5. What should we do in this case again? Yeah. I know you're saying it. So that should be 3 times Q, and that will give you 3Q. And of course, now you see 3 is positive and 5 is negative. So positive and negative will give you negative. That is, positive multiplying negative will give you negative. So this is 3 times 5. So 3 times 5. And that will give us 15. Good. Okay, can you try the last 2? You can pause the video at this point, and then you just come back and see what the result is. Okay, so imagine now, well done. If you have paused the video, I believe you can now look at what the solution is. So 7 into the bracket of 2m plus 1. Now, when you look at the ones we've done earlier on, they are just X. They are single letters, right? Single letters, single numbers. So, but in this case, this is 2. We have 2 numbers, right? This is a term. We have 2, and then we have a variable, a constant and a variable. Now, it's like what we did earlier on, or as well, when we are looking at how to multiply a number like this, 4x times x. So here, what you do is you multiply 7 with 2 and with m, right? It's the same thing, we had said in between 2, when you have a term written like this, that is 2m, 2m is the same thing as 2 times m, and now we have it again with 7. So you see, it's 2 times m times 7. And what would that be? 2 times 7 is what will give us a factor. 2 times 7 would, of course, be 14. And the m would be 14m. Good. And now we can move on to the next one, which is 7 times 1. And that would be 7. All right? 7 times 1, that will be 7. And so we can look at the last one. The last one is negative 2 into bracket y plus 6. Negative 2 into the bracket of y plus 6. Now, what should we do here? Now, you see, in this case, this number is negative. So what do you think the answer would be? You can also pause the video at this point and check what your answer is with what I'm going to have at the end of the day. Now, here, this number is negative and the number here is positive. So remember again, when negative is multiplying a positive number, right? When negative is multiplying something positive, the answer will be negative. So already that's negative, and 2 times y would be 2y. Again, negative multiplying positive would be negative, and 2 times 6 would be 12. Now, this is a good thing for you to know that, again, I said a number, when it is positive and is the first number or is written alone, we don't write the positive sign, okay? So you have to keep those in mind. Now, if you have any question, do let me know. We're still going to continue on the series with algebra, expanding and factorizing. We have started with the simple tasks, and I believe you can do much more. We can do much more tougher exercises together, right? So I love you to subscribe, to follow, so you will not miss any of this series. Now, finally, I'm going to leave you with 2 questions for you to solve on your own. 2 questions for you to solve on your own. I'll put it over here. Can you expand 5x into bracket y plus 4? You can leave your answer in the comment section, and then I would see what you have. And the second one, can you expand 3y into the bracket of x plus 2? Well done. Okay, and thank you again. Remember to like, subscribe, and follow so you would not miss any part of this lesson. This is my grade advances, and we are still moving on the lesson about algebra. I'm so glad to always be able to help you improve your grade. And I always like to say about algebra that I know so many people are really terrified with algebra. Like, algebra just terrifies them. But I can tell you honestly, it's not that bad. Honestly, it's not that bad, okay? What you just need to do is make sure you understand and learn these basics. I've met students who can even deal with things that are more difficult in mathematics, but they feel, well, algebra, I can just handle it. Well, you just have to get used to it, especially if you are thinking of having a career in the field of science or technology or some other mathematical related field. You have to get familiar with this. And by doing that, you just need to understand and learn the basics for dealing with algebraic expressions, okay? And it's as simple as knowing some keywords that are being used. For example, when we talk about the word terms in algebra, you have to be used to what that means. What does the word term mean in algebra? When we say term, what does it mean? It means you have a collection of numbers, letters, and brackets, right? Like what you have here. We have a collection of a letter and a number put together, and that's what we could refer to as a term. So when you just have some of these keywords in your mind, you know their meaning, it becomes very easy for you to deal with. Okay, so another thing to keep in mind, which is always very important for me here, is your signs. That is, when I say your sign, I'm talking about the positive sign, the negative sign. Well, not so much with multiplication or division, because oftentimes this will not really be your mistake. They won't really, I said really, right? But these are the areas where students make mistake. They make mistakes using or forgetting to add, forgetting to take note of the positive signs and the like. So this becomes very important for me to let you observe in this lesson. So I would make an illustration. For example, if you still struggle to understand something, like when a question says for you to subtract 5 take away 3 and 3 take away 5. 5 take away 3 and 3 take away 5. These two expressions are not the same. Okay, 5 take away 3 is you are taking away 3 from 5. You have 5 things and you're taking away 3 things, that will be 2. But now you have 3 things and you want to take away 5 things. That becomes a little difficult. So usually, literally, you can just know that that will be a negative, because you want to take away a big number from a smaller number. Okay, my answer should be negative. Now, the same thing goes if you have to add negative numbers together. That is, this, what you have here as -3 and -5, that is -3 minus 5. You are adding negative numbers together, and that will, of course, give you a negative answer, which is -8. Now, but it becomes more different if it involves multiplication. So if we have -3 multiplying +5. Now, when it comes to multiplication, if a negative number is multiplying a positive number, your answer would be negative. But if we have it the other way around, a negative number multiplying another negative number, if there are 2 negatives, then your answer would be positive, and that will still be +15. Now, if you are able to pay attention to all of this in your mathematical journey, you will become a master of many things, because you make less errors while solving problems, and it will become more easy for you to quickly interpret, especially some wordy problems. Okay, now let's get back to the question of the day. We have write down an expression containing brackets for the area of the rectangle. Now, how will you solve a problem like this? If you have been thinking about it, I can tell you the first thing you have to think about is they want you to find the area of a rectangle. But now, in this case, you have not been given. What you have here is a term. You have a term x plus 5. It's not like the usual thing, probably when you have 2 here and then you have 3 here, and they ask you to find the area of the rectangle. You just do 2 times 3 and you get 6. However, here it's an algebra. So if we say something like, okay, the area of a rectangle, let me call that A, capital letter A, would be, we know the area of a rectangle is, say, length times breadth. Okay, so now I will take the expressions and put them together. The length is x plus 5. X plus 5. I have to put that in brackets, right? Because that is the length of one side. So I'm not just going to be confused, right? If you do not put them in brackets, you are easy to make errors. And in fact, the questioner says an expression containing brackets. But a very easy way, an easy way for you to handle this problem is for you to put it in brackets. Now, what is the breadth? The breadth is 2, so times 2. Okay, another good way to write this, if you want to write this in another way, is you can also interpret this as 2 into bracket x plus 5. These two are the same, right? It doesn't matter where the 2 is standing for the multiplication. Either it's standing on this right-hand side or we are putting it here. It's the same. And either we are putting multiplication sign in between the 2 terms, it doesn't matter. It's immaterial. So because brackets, as it were, when you do not put a sign between a number and a bracket, you know that is multiplication. So this is what the question expects you to do. However, to keep our skill of expanding brackets, you may have to multiply this out, right? 2 times x, right, will give you 2x. And again, you do the last one. 2 times 5 will give you 10. So that's an expression generally, but not in this question. The question says an expression containing brackets for the area, and that should be this. That should be the first thing we got, this one. Okay, this is not your answer. So you always have to pay attention to what the question is asking you to do. Okay, now let's look at the second one. Now, the second question is saying we should copy and complete this diagram to show the areas of the 2 small rectangles. Okay, now we have 2 rectangles here. One side of the rectangle is 2. And of course, one thing you must keep in mind is if this side of the rectangle is 2, that means this side also would be 2. The same way, if this side of the rectangle is 5, this side will also be 5. So we can call the areas of this rectangle, let's call the area of the first one, let's call that A1. And let's call the area of the second rectangle, let's call it A2. I'm doing this labeling because I want to make clarity. I want to avoid confusion. So for the first one, area of the the first rectangle would be length times breadth again, and that should be 2 times x. 2 times x, and that should give you what? 2x. Excellent. 2x. And then we can move to the next one, A2. And that, of course, will also be 5 times 2. 5 times 2. And that will be 10. Now, if you look at the last part says, what did you notice about your answers to this? The answer is just like, yeah, it's an addition, right? Did you see that? Or what else do you notice about that? You can leave that in the comment section. Please remember to like, follow, and share with your friends. See you next time. So moving forward with our problem solving, now let's look at this reasoning question over here, which says state whether each relation is an equation or an identity. And we are to rewrite the identities using the symbol. The symbol for identity, for clarity, is 3 dash line like this. And of course, you know, the symbol for equals means 2 dash lines written together like this. Okay, so now the next thing to ask yourself, if you don't know that already, is what is an equation and what is an identity? I will start with an equation. An equation is a statement with an equal sign, okay? And it's stating that 2 expressions are equal in value. For example, if you have 3x plus 5 equals 11, this is an equation. Of course, you may ask yourself, why is this an equation? This is an equation because this thing, well, all that we have here, that is 3x plus 5, is only true for some specific or for only one specific value of x. It's only true for only one specific value of x. And you can imagine, this is like asking you, what should be the value of x that will multiply 3? And then after that, you will add 5 to it, and your result would be 11. And if you think about that, you will realize the only value of x that you can ever put into this place should be 2. So the only time we can get that is 3 times 2 plus 5. Of course, 3 times 2 plus 5 would be 6 plus 5. And that will give us 11. So this is an equation. There is no other value of x that we can ever substitute. No any other value of x we can substitute that will give us the value of 11. Okay, so, but for an identity is also an equation which is always true. So another way to talk about this symbol is something that means it's always going to be true. Okay, for example, if you have 2x plus 3x, 2x plus 3x is also a type of equation. Now it's an identity because the result will be 5x. And this will be true for any value of x. If x is 1, right? If x is 1, then 5x will be equals to 5. If x is 2, then 5x will be equals to 10. If x is 3, then 5x would be equals to 15. Do you see that? So there are a lot of possibility when it comes to identity, but there is only one possibility when it comes to an equation. Now, can you quickly start to look at the reasoning question and start to leave your answer in the comment section? Which of the equations do you think are identity, and which of them do you think are just an equation? That is, which of them will you put the symbol of an identity, which means it's always true, or which one would you use the equal sign to say, well, there is only one unique value for that solution? So if we look at the first one where we have x times x, of course, you know that that is obviously an identity, okay? It will be true for any value of x. So x times x should be an identity, and that should be x squared. Okay, and then on the other side where we have 3x plus 4x minus x equals to 6x. Obviously, for any value of x, this is also going to be an identity. Okay, this is going to be an identity and not an equation. Because any value of x will satisfy that equation. Let's try it. If x is 1, okay, if x is 1, that means 3 times 1 will be 3, plus 4 times 1 will be 4, minus what? 1. And for us to know if we are correct, that means 6 times 1 will be 6. So if you had this 3 plus 7, 3 plus 4, that will be 7. 7 minus 1, that is 6. Okay, let's check again when x is 2. So if x is 2, we have checked for x equals to 1. Let's check for x equals to 2. Okay, if we check for x equals to 2, will this also be true for x equals to 2? Okay, let's see. Now, if we check for x equals to 2, so when x is equals to 2, we have 3 times 2, that will be 6. 4 times 2, that will be 8 minus 2. And to see if we are correct, 6 times 2 should be 12. So 6 plus 8 is 14. 14 minus 2, and that will also be 12. So the second one is also an identity. So we should change that and write identity. Now, what about this one? This, of course, too. What do you think about that? It says 3x minus 1 is equals to 2x plus 1. Is this going to be an identity or an equation? Please kindly leave your answer in the comment section, and then I will go through it. Thank you. Now, The other one here says by drawing rectangles, show that this 3x into the bracket of x plus 4 is an identity of 3x squared plus 12x. How would you do that? Now, this is trying to show you something like we did in the previous solution that we had, where we have a rectangle and then we have to find the area of that rectangle, and then we wrote an expression in brackets and we also expanded the expression and see what we. So obviously, if I want to answer those questions, what will I do? I have to draw a rectangle. Okay, and if you take the expression, take this off, if you take the expression, you have, for the first one, we have 3x into the bracket of x plus 4. And what is your formula for finding the area of a rectangle? The formula for finding the area of a rectangle is length times breadth. So if you take one of the side as your length and the other side as your breadth, then you would be able to draw a rectangle that represents those information. So for me, this is what we're going to do. So for the first one, I will draw my rectangle. It says a rectangle. And then when we draw that, we have something like this. And it says 3x and then x plus 4. Now, in my own opinion, it depends on what the value of x will be, except when the value of x is probably 0, right? That's when addition would be more. That's where you have maybe the length of one side will be 4 and the length of the other side will be 3. And if it is 2, you have 6 and 6. If it is 4, you have 8 and 12. So if you like, you can use any side. What we know is a rectangle is length and breadth. So which side are you taking as the length? So I would say the length for me would be like, say, 3x, and the breadth would be x plus 4. Okay, x plus 4. So that's one way to look at it. And if you want to, it says by drawing a rectangle, we want to prove that this will always be true. Okay. Now, if we want to do this, this is 3 times x. If you multiply that, 3x multiplied by x plus 4, that's the area. The area of a rectangle is length times breadth, and that will be equals to that. Now, if we want to write it on the other side, which is saying the area, now we have here 3x squared here is showing the area of one side, because when we square a number, that's area, that's area, right? And 12x is just a particular rectangle. So if we have, I can do something like this, such that one side, which is the length, is 12. I'm doing this other part where I have 12x, 12, and then this other part is x. Okay, so, and the length I have chosen is just from here to here. From here to here, this is 12, and from here to here, this is x. Okay, so for this other part, we wanted to check if that will be, says 3x squared. 3x squared. How do we go about finding the value of our 3x squared? That means one side, this side should be 3x, okay, and this other side should be x. And that will always be true, because can we check again? I have broken it down one after the other. 12x, one side I represented it with 12 and the other side with x, so that if I want to find the first area, like we did in the first question, area 1 would be 12 times x, and that will give me 12x. And the second area would be this side, 3x multiplying x, which is this side, and that will be 3x squared. All right, so that's how to check for all of those. So can you check for the B part and see what you would have if you check for that? Can you check for this part of the question and see what you have? Then I have got lots of question here for you on expansion. Can you try to, try your hands on them? Leave your answer in the comment section. I will appreciate it so much, so much. Thank you for always following, liking this video. If you need a personal tuition, you can always reach out to me. I sell my lessons perfectly differentiated for you. I know you can find lots of video online, but I can differentiate a lesson to help your understanding, your own specific understanding, which I believe is what you need on any topic. All right. So I'll see you again next time. Thank you. This is my grade advancers, and see you next time. Remember to lay your hands on these exercises. Then we'll see you next time.